Okay, just a moment. Yeah, basically we discuss the rules for debates and etc. You can write in. You can read it in the first lectures. Are you sure that your colleague?
Yes.
Sorry, because I not see. Unfortunately, I not see your colleague.
Okay, I'm telling him that he'll send you again.
Yeah, could you? Because I cannot see.
Okay, but the thing is that we've missed our first lectures because we have a problem with the mail of the HSE. So we don't know nothing about the debate. We don't know nothing about the final work, and that's it.
Okay. Are some of you also missed the first lecture? Who else missed the first lecture?
And the one that sends you the link now.
Let's check.
You have recorded the first lecture, haven't you? So now everyone can see just the recording and be aware of everything we talked about.
Yeah, Nikolai is right. Actually, all materials you can find in LMS. Yeah, in first lecture, I tried to extremely in details explain the rules for grading, explain the part of your grade. It's like 3 parts, as you know, debates, group project, and test. And we discuss now with colleague why the grading for debates is kind of maybe not typical because we have rule in HSC. Maybe your students discuss it. It's a new rule for this year about the distribution of the grades. I know that is really sensitive and painful issue for you, and we discussed it during the lectures. I'm not like, let's go for the right. Yeah, it means that you may ask this question because you have subjectivity as a student and your vote is count. And if you don't like the system, you may ask questions why we have this. Okay, then please read the first lecture, okay? Because we have this situation. Maybe you have heard about this. Because I discussed maybe in Russian, but with your colleague about this.
Yeah, but we don't speak any Russian, so when another colleague has something, we don't get nothing about it. And another thing, do we have to submit anything yet or not? Such as the groups for the debate or?
No, look, again, just a small repetition, sorry, 5 minutes for your time. Debates, you just present your position, yeah, based on the distributed topic. Yeah, like normal debates. And because we have bigger groups, we discuss that additional people join the group. I think that I don't know why it's happened, but I told that like more 24 people came from different program. Do you know something about this? Not you exactly, but other.
No, I don't know them. I only know the Spanish students.
Yeah, I know. Yeah. Someone want to say something? Sorry, I cannot hear you. No one want to say something. Okay. Okay. We came from quantitative methods of finance. Yeah, what What happens? Sorry, can I spend 3 more humans? What happens with quantitative methods of finance? Why you came from there? I mean, the name of the course is quite good. Something happened that you cannot attend time or what? Ah, okay.
And when will the debate will be?
For you, like, do you receive the letter from me?
No, is what I'm trying to tell you.
So you do not receive any letters from me?
No.
Well,
maybe it's in Russian and I don't know if you're talking or some others, because I can't even say the name of the
topic. Was in English.
Then no.
I letter in English about the name. I think for you it will be, let's see. Can you see your name?
I think I'm the number 15 on your list.
On 28th of November.
28th of November. Okay, thank you. And my colleague too, Pablo del Ejido?
I think, yeah. I think,
okay,
and your, sorry, I've mispronounced your name, Linaro Sitora Arnau?
Yeah. Yeah, you said it, but
you will be on 28th of November.
Okay, thanks.
29, sorry, 20.
29.
29. It's like 2 lectures now. I missed it. Okay. Evgenia, yeah, from the finance. We told that you probably, these people from the finance will be on the 29th of November too. And in this file, yeah, for those, oh, come on, you need to create, you already did it. Yeah, this and other people, please add to the command that have less than 5 people. For instance, we have this command, that command, yeah, and so we have like, oh, sorry, no, this one, yeah, we have 2 debates for 15th of November, yeah, and someone if want to can join the group, so the 15th of November, other join the group for other time, yeah, with the people. And 2 more seminars, 2 more debates we will have on the 29th of November. Yeah, those who were from the quantitative methods of finance do understand the idea how you need to distribute for debates, because it's crucial. Yeah, Evgenia, could you say your colleagues? So please, we have like, so we have, so like 3 additional groups, you can form your groups. Yeah, so, but no more than 22 groups. Yeah, otherwise, please add to the people who have less than 3 people in the group. Cool. And then because of that, I changed a bit the procedure of these debates, because first it will be 4 rounds. Yeah, according to the first lecture, it should be 4 rounds of like presentation, but because of we have like 5 person groups, it will be 5 rounds. I will write you later today. So like small I just show you for you. Okay, you cannot see my screen. Sorry. Just again, let's discuss a bit this stuff. Okay, now you can see. Look, first it will be, or it should be like 4 round debates. Yeah, because before this finance came to the course, we will have smaller groups, but now we have like many people in the group, and then it will be 5. So like it will be introduction speech, then 4, three normal argument speeches, and then final speech. So it means we have 5 rounds of debate, and it means that all people in the group can present. So if you have 5 people in the group, all people in the group have chance to say something to present their position in order to get a good grade.
So every team will have 3 main rounds and the final one, or not, or 5 main rounds and the final one.
No. Introduction, 3 rounds, and final speech.
Okay.
So 5 rounds, no, instead of 4, it will be 5. So if it's only like 3 people in your group, I don't know, it means that someone need to speak twice, or of course, I encourage you to do this. If it's like less than 5 people, you can share 1 round with your colleague. It means, for instance, you speak 3 minutes, another colleague speaks 3 minutes, for instance.
Okay, I see.
So let's do it in this way. I change the rules for this round stuff, and I, for instance, created the new presentation for debates with this, like, instead of 4, I say that it will be 5 rounds and send it to you. So other rules does not change. Nothing changed otherwise, yeah? But we have more rounds of the debate, that's all. I think it's clear, it's nothing really difficult.
Okay.
Okay, I hope. Okay, let's start today. Basically, today we have our so-called method seminar, empirical seminar. So for one seminars we have debates when we discuss empirical topics, and we also have 2 seminars that we discuss some methods that people usually use in order to solve these empirical labor problems. And I do it in that way. Just a moment, I just show you only the presentation for you to see, and for me to see your chat if you have any questions. Unfortunately, sometimes I cannot see if you use this hand sign in the Teams. So please write in the chat, or maybe just turn on your mic and speak, because sometimes if you want to ask something, I cannot see this hand sign and I can miss your question. So please just use the mic. So so we have the seminar today, and we have the seminar on the 22nd of November. It's just we continue as a seminar, the second part of this empirical seminar. It's just for you to know that labor economics is usually about empirical research. Yeah, and this empirical research usually demand specific methods. And one base method that used another really useful procedure for labor economics, it's called Heckman correction, is different logistic models. Basically Logit and Probit regression. First, simple questions. Do you have any econometrics preparation? Do you have any econometrics course? I know that some of you may be not from economic major, so I ask these people, if you are not from economic major, do you have any basic statistics or econometrics course? Why do I need to know that? In order to understand, do I need to explain something in details, or maybe I do not explain more complex stuff in detail because you already have heard some basic probability theory, You're already known with the concept of OLS regression, with the concept of external validity, knowing the basic assumption for OLS, like central limit theorem, or rule of big laws, and something like that. Could you say, or maybe write in chat, what about statistics in U? Could you react somehow? Anton, it means that you already known with the main notions. Yeah?
Yes, but he is one of the guys from economic major, so.
So, like everybody of you from economic major, yeah? Or Anton is only from economic major?
No, so I am from economic major and some other guys too, but
Okay, if you have you have your econometrics course, no?
on our economic major, yes. So we are passing through it right now. So from the beginning of autumn, so we are aware of all the concepts you have mentioned, but we are not sure about other participants.
Okay, thank you. Yeah, could who are not from economic major write in chat, because I need to understand how many people we have in this group. Sorry, because it's a mess. Yeah, your program, I know I complain a lot about your program office, but your program office is awful. I do not have even now the list of people from my course. Yeah, thank you, Evgeny. And you know, even now, I don't know how many people on my course, and basically, I even don't know even names, because you say it, for instance, yeah, that you do not have your HSC mail, yeah, and you cannot register for the course, and because of that, you missed your first lectures. I mean, for teachers, the situation is not better. We have the same mess as you. So because of that, I may ask you some clarification stuff. Okay, why? Now we speak about so-called logistic regression. Yeah, and this is a part of more complex problem that we solve in framework of the labor economics. And you know that all complex model based on the real simple stuff. So the basic regression models is just OLS, yeah? If you're now learning with Покровский, да, у вас Покровский for the econometrics. Who teach you
Vladimir
econometrics?
Николаевич Пырлик.
Пырлик. Okay, then yeah, so then you definitely discuss the assumption for OLS, yeah? And now you can tell why OLS is not the good decision when you want to find the dependency of y of your dependent variable on your independent variable. What is the main problem with OLS regression? Is Russian is M and K. No, basic linear regressions. What is the main problem of it? Do you discuss assumption of this regression?
Yes, we did. So
What is
it has many problems.
Yeah, but what is the most problematic that's always violated in real life? I know that you have heard this word. Something about endogeneity.
Yes, we are currently in the starting of that subject. Let's see.
Yeah, but could you do you know what endogeneity is?
So
if you see something, probably you have known that.
basically, as I have understood from the last materials, it's the problem when our regressor is connected with our error, and
Yeah,
it shouldn't be the case, because otherwise our model can't be named model,
yeah, it's
regression
kind
model.
of BLUE, best linear unbiased estimator. Yeah, probably you have heard BLUE, BLUE, best linear unbiased estimator.
Not yet, probably.
I think it's not so elegant in Russia, but in English, like BLUE models. Okay, so what type of dependent variables you use when you run this Euler's regression? Okay, what type of variables do you know? What type of variables? You know this from statistics. What types of variable can you have in your regression?
So like numeric or factors, something like that, dummies.
Yeah, something like that. Something continuous variable, for instance.
Yes.
That sounds similar, yeah. Then a categorical variable and dummy variable is one of the specific, how to say, I forgot the word, sorry.
Type.
Specific type, yeah, specific types of this categorical variable. So in OLS, you usually have as your dependent variable continuous variable. Can you say some example of any continuous variable?
For example, wage or
Yeah,
GDP, something like that.
yeah, wage. Simple, yeah. Yeah, Evgenia, you're right. You're right too. Wage. So if we speak about dummy variable as dependent variables, we cannot run simple linear regression. In this case, people stick on the so-called logistic regressions. Probably, I'm not sure whether you're going to discuss this in details in your econometrics course. And during the seminar, I just explain you the idea and in what cases you need to use this Probit or Logit models. So I'm not going to show you many maths that lie behind this model. I need for you to understand in what situation you may use this model. So like more empirical parts of this. Yeah, so if you're interested in this technical stuff, you can go to the Wooldridge introductory econometric textbooks. Have you heard about this? Wooldridge?
Yes, of course.
Yeah, and more basic stuff. It's Stocker-Watson introductory to econometrics. I don't remember whether Stocker and Watson have this Probit and Logit, but it definitely have something. I mean, based models like instrumental variable, etc. Okay, so basically this logistic regression is used to predict a dependent variable that basically takes values 0 or 1. And this is really simplest model on this logistic regression. So regressions are based on the prediction of probability. For you to know, there are many ways to predict the probability. I mean, many models, many different, more advanced type of Probit and Logit. One is ordered Probit, ordered. In Russian, порядковый Probit. Why I translate some names in Russia? It's not because I like give some advantages for Russian speaking people, just because they learn econometrics in Russian instead of you, for instance, yeah, who learn it in English. And sometimes for people it's really hard to, to get the names of some models in English if they studied it in Russia. So maybe they know the concepts of this model, yeah, already, but they cannot coincide it with the English name.
Unfortunately, as the matter of fact, we study econometrics in Russian too right now.
It's not unfortunately, it made it better to understand, and because of that, maybe I translate something. I mean, there are some non-Russian speaking people in the group, so like I just translate for those who speak, who study econometrics in Russian. Okay, so-called ordered probit in English, порядковый probit. Have you heard about this? I mean, of course you have not studied this, but have you heard at least?
Not really.
Okay. This ordered probit, you need to, is the same, yeah, predicted probability. So the one more advanced type of these logistic regressions. And you need to use it when you use indexes, yeah, as your dependent variable. What is the problem with the indexes? Think about this. For instance, we have indexes for, I don't know, satisfaction of job from 1 to 5. 1 is not satisfied at all, like the nightmare. My job is nightmare, yeah. And 5 is my job is super cool and I'm so satisfied with that. Do you think that distance from 1 to 2 in these indexes is the same than distance from 4 to 5?
It could be, but it's not necessary.
Yeah, because like, for instance, moving from nightmare and bed, it can be different change in the position of person, moving from I'm good with I'm super good. Yeah, I understand the idea. Because of that, we need ordered probit. But if we have just categorical variable, for instance, employment status, yeah, from 1 to 5. 1 is, for instance, paid employment, 2 is unemployment, 3 is like part employment, and etc. Yeah, it's just category, it's not indexes. It does not mean anything that you change the number for each category. It's just category, yeah, it's just a sequence. It's not indexes. For this, we need to use so-called multinomial logit. We are not going to discuss it because it's like specific stuff. We discuss just basic idea how to interpret all possible regressions and based on the probability. Why do we need this? Because in the second, our empirical seminar, we discussed so-called Heckman correction procedure is really useful instrument for labor economics and for other part of economics too. And for this, we need to understand the concept of probit because the first stage of this correction procedure based on this probit. Okay, you understand the idea, yeah? Basic logit of probit, if the regression with the dependent variable equals 0 or 1. So the binary outcome. Yeah, you know that all regressions have assumptions. Yeah, the logistic regression have assumptions too. First, your dependent variable, of course, should be consist of the binary outcome. Then you have 2 or more independent variables that should be continuous. That should be continuous or nominal. So it can be categorical variable, it can be continuous variable, but it should be 2 or more independent variables. So then you should have so-called independence of observations. Yeah, it means that you have no repeated measures, and also ideally, yeah, you know from the econometrics that it should be identically independent distributions. I don't remember how it in Russia.
Независимые, одинаково распределенные случайные величины.
Yeah, you're right. I think because, like, I did like independent distributed. It sounds better than in Russian. Sorry for that.
Yes, it's
You
true.
understand?
It's just true. So we write just I point D point. So
Yeah. So yeah, I understand the IID is more easier. Yeah. So then your data must not show any multicollinearity. So from the econometrics that simple questions. If you have collinearity like 95%, will be the problem. Collinearity of two independent variables of 95% should violate the assumption of OLS or not. Do you discuss collinearity as assumption of OLS? What mean from the rule? What collinearity violate our assumptions?
So we haven't discussed the exact question, but we were said that when we have the exact collinearity, it's obvious that it's not okay. But if we have a strong case around exact collinearity, it's an interesting case, and that was all about it. Let's say so.
Yeah, but theoretically, only perfect collinearity, as you said, like exact 100%, violates your assumption. Yeah, it means that, theoretically. But I told that we have different tests that shows you whether we have problem of multicollinearity or not. Maybe you have heard for OLS it's called VIF test. Do you discuss it? VIF test? No? Okay, maybe you discuss it later.
Maybe.
Sorry?
Maybe. So at that point, I believe we were just set to something like think about your variables and extract their meanings, and so think can there be collinearity or not, or just build some sort of matrix of correlations. So we didn't discuss some functions to extract the exact multicollinearity.
Yeah, but I just told you, for instance, I think in the R is the same. In Stata, it's just VIF command after the regressions, that's all. It's not so difficult.
But does it show the problem variables?
Yeah, it shows you some numbers for each variable in the regression and number for whole regression. And if it's higher than 10, then you have the problem of multicollinearity.
Okay.
If it's lower than 10, then you're okay. But be careful. Of course, it will be higher than 10 if you have quadratic relationship in your equation. Because you have what? You have normal variable and square variable. Yep.
So basically, they are collinear. They should be.
Yeah, because the same variable. Yeah, obviously. Yeah, so then the next assumption is like should be linear relationship. Yeah, between any continuous independent variable and this Logit transformation of the dependent variable. It's our binary variable.
So
yeah,
we can't use something like something like models with logarithms or quadratic or triadic ones.
No, you can use because it's like not so obvious with the. No, you can. This is because of this based on the probability. It's not the same as linear relationship with the is in OLS. And later in this seminar, I show you test to show you whether you have this problem or not. So it's not like the same idea, just real linear, because look, this linear relation between this Logit transformation, it's a bit different. Okay, we have this assumption, but we also have test that shows you whether our functional form of equation is okay or not. So you do not care now, but you can run so-called post-diagnostics. Yeah, post-regression diagnostics and check whether you have this problem or not.
Okay.
So no problem with logarithm, no problem with a quadratic relationship in Probit. Of course, you should use it when you decided that you need it. And then, of course, the next assumptions crucial. It's like no significant outliers, no high leverage points, or no high influential points. And I'm sure you discuss it a lot in econometrics, yeah? Do you discuss outliers in econometrics?
Yes. So they just push our dispersion up, and
Yeah.
it's a bad case, because in that case our coefficients will be hard interpreted.
Yeah, and it can be not also extreme high values, it can be also extreme low values. It can so-called push down. I mean, shift your mean towards the left, shift your mean towards the right, and then you have no external validity. I mean, your coefficients cannot be interpreted. And if you need, and okay, what statistical software you use for your econometrics? Probably R, yeah?
Yes.
Because
So yes, that's why.
Do you study Stata?
We don't actually. So it's one more time the problem with licenses.
Yeah, but
always.
you know, have licenses from HSC.
I believe we they в общем, у них срок кончился, по-моему. Там же он не бесконечный был.
No, you can download the new licenses till the next October. If you need it. Okay. Yeah, I know, Victoria. I know that you study with me. I mean, maybe you studied in other course. Because of distance learning, because many people not from economics, Evgenia, it's about your comments. We are not going to have econometrics homeworks like, for instance, you do with me in the last year. Our grade will be only 3 parts. Yeah, debates, group project, and tests. In tests, no econometrics, don't worry. I mean, no Stata. Yeah, I can probably no econometrics. It's just for you, yeah? Like, in normal way, if we have normal learning, we will have some econometrics homework dealing with the solving of the real empirical problem. But now these seminars is only for you to know the new methods, and maybe you decided to use in your term paper, for instance. It doesn't matter. I mean, R and Stata is quite similar. Even if you use R, is approximately the same command as in Stata, and you can download the same additional block, so-called in R, for the command in Stata. For instance, Heckman correction, Nexaka-Blinder decomposition that we will discuss in the next seminar. There are some specific additional, how it calls, you understand, yeah, specific additional packages, yeah, packages.
Libraries. They're called libraries.
Yeah, libraries. In English, libraries too. No, libraries. Packages. Yeah. Okay, libraries. Yeah, there are specific libraries for R2 with the same command. So if you want to run these commands, no problem to run it with R if you prefer R, for instance. So Stata is more, you know, user friendly. That's all. Yeah, it's more easy to do some stuff, and you have low chances to be mistaken because of wrong code, something like that. Yeah, but no, don't worry. Just because I just prefer Stata. Sorry, we have example for Stata, but it's the same form, so no problem. Okay, no outliers. How to detect outliers? What is the most simple way to detect outliers?
Box plots.
Yeah, just simple. And what you do with outliers?
We can do. We can deal with them in several ways. For example, we can just delete those observations, or we can replace them with something like mean, but only if there is a need for it. So if we have not so much observations and they are crucial for us, but if we have thousands of them, so we just drop them, right?
Yeah. So the most easier way to do this. Okay. Probit and Logit. In this picture, you see the distribution. Of course, distribution is based on different ideas because Probit and Logit is different. For Probit is so-called function of standardized normal distribution. For Logit is function of logistic distribution. But you see, it's quite similar. Yeah, and because of that, both models provide you similar results. So it means that Probit and Logit provides you approximately the same results. Of course, coefficients will be different, but signs for these coefficients will be approximately the same. So sometimes if you use Logit and Probit, you can use Logit or Probit. Doesn't matter. But because of this difference in distribution, for instance, if you want to use Logit and Probit with the panel data, it can be kind of challenging because when you combine panel data and Logit and Probit, for some models, you cannot combine it. I mean, for some cases, you use only Probit with panel, what's the not coefficients, with a panel structure. Let's call that, and sometimes Logit. But I mean, we are not going to discuss panel data. Some of you will have later, because it's other complex ideas. It's just for you to know for future, maybe. Yeah, it's like click something for future, that just for you to know. Okay. Okay. Some of you are going to have with me and Alexander Alexandrovich Muravyov this panel data course, I think in the fourth model. Are some of you going to have this panel data course?
Yes, we are.
Yeah, so we do not discuss during this course Probit and Logit, but we discuss different panel modes. Basically, it's not so difficult, don't worry. If you survive the econometrics with Pokrovsky, so you survive the panel data, and panel data will be a more easier than with Pokrovsky, because our course, yeah, we prefer like empirical econometrics. So we prefer like explain and discuss how you interpret the results, and the main idea of this, that you know what methods you can use in different situations and what the basically shortages of these methods. So the main goal for this, yeah, you need to understand shortages of this methods, yeah, and you need to understand in what problem you can solve with that. small future, yeah, teaser for this course. Okay, this is just code for starter, but do not worry about this. You need to understand how to interpret the table, because you get the same table approximately when you use R. I know that some of you, even not some of you exactly, but those of you who have the people from a double degree program say they study Gretel. So you say that, please do not, but some people use Gretel. Do you know? I mean, it's not obvious choice, but Stata is more, widespread than Gretel, MATLAB, or Python for statistical stuff, because MATLAB is for usually engineering stuff, Python is for text information, but not for statistics. Of course, you can run this regression with Python, but it's not like specific statistical software. Okay, no worry. But R is the same table. What do you need to understand? Yeah, pseudo R square in this Probit regression is not the same that R square it's not the same that R square in the simple OLS. Do you remember interpretation of R square in the simple OLS? What R square shows us?
It's the percentage of explanation given by independent variable to dependent variable.
Yeah, right, but not like exactly percentage. The percentage of variation in your dependent variable that can be explained by your independent, like variation of, because statistics is always about variation, distribution, and probability. I mean, yeah, but technically you are right. Yeah, so this is not the same. Yeah, so please do not interpret this pseudo R square like normal R square. Then what do you need to understand? This is two-tail p-values. Basically, it's the same as the t-statistics in your normal OLS regression. Yeah, it basically tells you whether you have significance in your coefficients or not. This one coefficients, crucial. You cannot interpret the coefficients in the same way as you do in OLS. These coefficients, because are in log odds units, because we have probability regressions. And in this way, it only shows you direction on your influence. In this example, our dependent variable is whether to work in service sector or not. So 1 is service sector, 0 is no. We see that experiences, labor market experience, do not significant influence. But female, our dummy variable, have significant influence. So it means that if individuals are female, it increases the probability to work in service sector. So Probit and Logit, it's always about probabilities. So it's basically shows you probability to be in group that coded by 1. So probability to be in specific groups. If we have group coded by 1, it's like work in service sector, as its probability to be in service sector. Yeah.
So does mean that if a person is a female, her probability to be in a service sector is greater than the probability of male ones by 1.23%.
No, again, look, you cannot interpret this coefficient like an OLS. You can interpret only sign. It means that, as you said, the probability of female to work in service sector is just higher compared to men. That's all.
But can we measure the delta?
Yes, it's good. It's like interpretation of R-square. Please read it at home. Yes, we can measure, and it's called marginal effects. In Russia, it's called предельные эффекты. It's called marginal effects. First, we can measure the probability that given that all predictors are set to their mean values. So the probability to work in our case in service sector is 27%, given that all predictors are set to their mean values. So the classical marginal effects, it's usually a marginal effect at means. But maybe it's not so useful. We also can calculate the probability of specific size effect for each, for each variable. And in this case, if you calculate the marginal effect, here's a marginal effect. You can say what? Now you can interpret the marginal effect. How you interpret this marginal effect for women? I mean, of course, it's written there, but as you said, with these coefficients is the same. So if individuals what are females,
so
yeah.
So if individuals are females, it increases the probability of being in a service sector by approximately 22.8%.
Yeah, compared to men.
How it is called in English в среднем при прочих равных?
Other things equal.
Other things equal. Okay, and okay.
Yeah, and sorry, I interrupt you. What do you want to say?
То есть other things equal это при прочих равных, а как именно в среднем? То есть, ну, там...
In average other things equal.
Okay. In average other things equal.
Yeah, you're right, you're good. But you know, it's funny stuff that usually in articles you cannot see this phrase in average or other things equal. People just hide it. Not hide it, but do not write it. Well, I mean, you're of course you always think that in other things equal, but usually in articles people do not write it.
They just don't write our small quizzes where we are being graded lower for not adding those words. So
yeah, I know, because you have econometrics is Pokrovsky, Pyrlik. Yeah, because because it's right. Yeah, you always need to think this and other things equal and average. But I mean, of course, you're good that you know that. You must know that because it's like basic line for this econometrics. But do not be surprised when you read an article that people usually do not use this phrase. I mean, they assume this phrase, but they do not use it in the text.
Okay.
I mean, people usually do not, I don't know, calculate by hands the B0 and the beta 1 and beta 0, but I'm sure that you calculated by your hand these parts of the OLS regression.
Of course we have.
Oh yeah, because you have like econometrics course, yeah, you calculated this like beta 0, beta 1, and etc. Yeah, but okay, but at least you know how it comes, yeah. Okay, this is so if we have continuous variable It means that the change in probability for one instant change in, for instance, experience, if we suppose that it was significant, is approximately like smaller than 1 percentage point increase the probability to be in service sector. So like for continuous variables, the same. Increase in 1 increases the number of this marginal effect in probability to be in the outcome of your binary variable that equals 1. Yeah, you get the idea. Do you understand how we interpret this marginal effects? Yeah, it's the same. So again, do not interpret coefficients from the regression. If you want to get size, you calculate these marginal effects. So then, diagnostics. As you said about this linear stuff and etc. We have so-called link test. Usually link test is like help you to understand and to detect a specification error. Yeah, because we have this assumption about linear combination. Frankly speaking, I don't know whether this test exists in R, but instead it exists. But probably in R too, but I do not Google it, I don't know really. So if you want to do this in R, please Google it. I'm like 90% sure that it should be some library based on this logistic regression diagnostics tests. So basically, you can type this just link test. Yeah, then this is interpretation of your test. Then if we have again this specific variables is significant, then it means that we may have specification error. Yeah, in our case it's not significant, so no problem. But if it's significant, it means that we may have the specification error. So what to do if we have this? Yeah.
Where do you check the significance? Where to look?
Like here. Look.
Okay, so it's the significance of every coefficient here.
Oh, so, look. This is just predict some variable like head square. Yeah. And this significance of variable head square shows you whether you may have the specification error or not. That's all. So you just type link test. Okay, like you get this after the regression. You get this table. I think in R it should be looking like that. Is the name of the command. Yeah, this is what happened. I'm not going to read from the slide because you are adult people, you can read from the slide. I just explain the sense of this. Yeah, and then you check whether this variable head square is significant or not. Yeah, so if it's significant, then it confirms that you chosen meaningful predictions. It means that your independent variable really somehow explain your why. But in the same time, it also tells you that you may have the specification error. Yeah, and if you have the specification error, it means that your model is not so good quality. Yeah, because you have the specification error, basically. And what to do if you have this problem? You need to check whether you include all relevant variables. Maybe you need to add additional regressors. Then you need to choose whether you use a relevant form of variables. And this is questions about whether do we need to use logarithm. Yes, we need logarithm. Because if we do not use relevant form of variables, we may have these specification errors. Yes, it's, I mean,
okay.
Again, when we need to use logarithm of our variables,
we need to use it if we have some intuition or theory that we would like to see the change in percentage.
Yeah, but there is some like strict rule when you definitely need to use logarithm. When you need to use the logarithm, in case if your variables have what kind of distribution? Log normal? Does it ring a bell?
It does, but we were said that we are working on a large number of observations, so we don't really care about distributions. So we just say that it is going to be normal on a large scale. So
Yes, but you may check the distribution. Yeah, even if you have large scales, you may have still log normal distribution for weight, for instance.
maybe, but we don't do that. So we're told that it's not a good way.
You're right. You're right. You don't care if you have a large number of observations. You're definitely right. It's definitely the case. I mean, the easiest way to do is just check the distributions. That's all. And if you see that, Anton, what you ask, no, you can, but I mean, the simple Probit Logit you cannot use, but you can use so-called multinomial Logit regression or multinomial Probit. I mean, in general, answer is yes, but it's not just simple Probit, it's multinomial Logit. Everybody can see the questions of Anton.
Yes, we can.
Good. This is what Anton wrote. This is called categorical variables. And for this, you need to use, again, multinomial Logit or multinomial Probit. And this is multinomial Logit and Probit. The impression will be the same. You have the same marginal effects. So it's always about marginal effects in Probit, but you need to compare. Compare, because you need to interpret the results, compare with the base category from this multinomial logic. So like multinomial logic with categorical variable, the logic for interpretation is the same when you interpret the categorical variable. How you interpret the categorical variable as your independent variable in the regression.
So we interpret. So we create n-1 dummies for that variable, where is n the number of categories in that variable, and we are naming the excluded one as a basic one, and we compare our dummy variables to that so-called basic one.
Yeah, the same with the logic. So this marginal effects will show you probability to be in some categorical, for instance, 0, 1, or 2, compare with the based one. If your category, for instance, 0, yeah, then your marginal effects for 1 for some variables shows you probability to be in category 1, compare with the category 0.
I've got a question.
Yeah.
And if a hash squared is not significant, so
you have no problem. It's
okay. So we are seeking for it being not significant.
Yeah, so you have no problem. So like in the other tests, yeah, like in the other tests, no significant result, no problem. You're good. Again, I need to switch. For instance, yeah, here, this is a test. Like instead of, because you do not have normal R square, but you may run this goodness of fit test, so-called, and in order to check whether you have normal specifications of model, it means whether your variables really can explain your independent variable, like R-square basically told us. Yeah, and this goodness of fit test shows you, of course, p-value for the test, and then shows you so-called cover rate patterns. It's like, yeah, basically like a variation, yeah, for your dependent variables. And then the number of observations. What you need to do, you just need to compare with this number of patterns that you get from this test with the number of observations. And first, if you cannot reject zero hypothesis, so if you have high p-value, and then if this number of patterns lower than the number of observations, then you are good. So nothing happened. It means that your models fit reasonably well. It means that your independent variables that you include in your models, good. I mean, fits well to your sample for explanation of your dependent variable. If not, then maybe you need to add additional variables, or you need to change their forms. The same logic like with the previous test. So these two tests tells you whether your model, like specification of your model, is good or not. Then really simple test for multicollinearity. Yeah, it's called Colline. Yeah, and it can show you whether you have the problem of collinearity or not. For OLS regression, you can use test called VIF. Yeah, just type VIF, and if it's higher than 10, then you have problem of collinearity. If no, then it's okay, no problems. Okay, so this is just for you an example that really Probit and Logit gives you approximately the same result. This is just regression, no marginal effect, but look on the signs and significance. The same signs, the same significance.
But significance is different, so at some point it can be crucial.
Yeah, but look, we have significance at least 5% level. Yeah, you're right. If you have like so-called border significance, for instance, significance on the border of 10%. Yeah, you see that, for instance, significance for Probit, what? Higher or lower? It depends, yeah, on the variables. For instance, the statistic is lower compared to that. So if you have like border case, Logit can show you significance and Probit show no significance. In this case, probably you have no significance because you believe only in robust results. Do you discuss robustness of your results?
Yes, so we just need to implement the assumption of how is it called in English?
What do you mean? What assumption? Could you say it in Russian?
Непостоянность дисперсии ошибок.
Okay. Like untemporary dispersion of errors, something like that.
Yes. So, for which we should use White's matrix.
Yeah, or robust. But usually in empirical studies, you can check your robust when you use different models also. And also one way to check robustness of your results is to change your sample. I mean, it's like two most popular way that people usually use in empirical research how to check robustness of results. So if different models give you the same result, then your results are robust. I mean, of course, it can be problem with violation of assumptions, but I mean, if like Probit Logit gives you approximately the same, then you definitely have this. Not definitely, of course. With high probability, you have this influence of your independent variable and your dependent variable. And if you change a sample, it's easy to understand. For instance, if you study the labor market, yeah, how to change a sample? You study, for instance, on the Russian level, aggregate level, yeah? And you can change it when you draw, for instance, Moscow and St. Petersburg. And if you see that results does not change if you drop two big cities, then it means that probably you have these links, yeah, between your independent and dependent variables. If results change, it means that Moscow and St. Petersburg somehow influence your results, influence of your coefficients. And in this case, St. Petersburg, Moscow is kind of influential outliers. It doesn't mean that we need to drop it. It means that the process and the labor market of these two cities is not the same that process, for instance, in Oryol, Ufa, or something like that. Yeah, in other Russian cities. It just say that we have different labor markets for these two big cities. And basically, it's not like really news for you, I think. Yeah, I'm sure that you understand that Moscow and St. Petersburg is not like typical Russia. Yeah, and then it can be quite different in terms of wages and labor market compared to other Russia, to other parts of Russia, because Russia is kind of big. I think it's kind of understandable. Okay. This is just a way to do this. You see, it's simple. Run the regression, then get the marginal effect, and then different post-diagnostic tests. What is more interesting, I show you example from the real articles when people try to implement this Probit or Logit models to solve the real empirical economics problem. Look, first articles, in the name of the articles, if you're interested, in the bottom of the table. These articles are about predicted probability of be self-employed or paid employed for married female college graduates. Yeah, and they just check how different independent variables influence on probability to be self-employed or paid employed. Yeah, it's about China. So that's one question. Yeah, probability to be in employment, to have a job, basically. The other questions, for instance, this is articles about probability to get a university degree, like college, it's mean higher education. It's like probability to go or not to go to college. Again, yeah, we have like 0 and 1 model. Be in college and like no college. Here example, for instance, probability that firms provided on-job training. So basically the question is what factors influence on probability that some firms provided their employees, yeah, on-job training. Again, binary variable is like 0 and 1 dependent, yeah. Have job, have on-job training, do not have on-job trainers. What are values? Look, if you don't understand values on the breast, look, this is node. Yeah, and usually people write what's the values on the scope. This is usually standard errors. If you have, sometimes people put in the parentheses marginal effect, but you see that their marginal effect is like separate columns. It means that this is a coefficients with the errors for coefficients. Yeah, like from the regression. This is a marginal effect, the significance of marginal effect, and errors for this marginal effect. Okay, usually people say what we have in the brackets. Yeah, like marginal effects, standard error for Probit summation, and so the first two columns you look, yeah, estimated marginal effect and the standard errors. Estimated marginal effect, standard error in the brackets. Here we have the same standard error, coefficients, and marginal effect.
But we don't interpret the coefficients, right?
Yeah, interpret only sign, like positive, negative, and etc. Interpret marginal effect. Here, look.
And in marginal effect, do we interpret their sign?
Yeah, of course. Like the size plus sign, like positive effect, like increases probability by percentage point, yeah, or decreases probability by some percentage points.
And can there be a situation where the sign before the coefficient is different from the sign before the marginal effect?
Yeah, sorry, I interrupt. No, because the marginal effect basically based on the coefficients.
Yeah, I understand, but maybe it can.
Theoretically, no, and really have not seen any situation when we have this kind of like difference between signs. No, if your coefficients is negative, marginal effect is negative too.
Because in that case, we just don't need the column of coefficients.
Yeah, you're right. We do not need the column of coefficients.
Okay.
Sometimes people, how to present this? They present coefficients, and in the brackets they present marginal effects. Like coefficients and marginal effects in the brackets.
It's
sorry.
It's pretty strange yet, because if we don't interpret them, so why do we need them?
Yeah. So like I just show you how in the real articles, like published articles, people present results. Here, look, this is presentation only marginal effect. In this case, people present coefficients plus marginal effect. Yeah, it can be both ways. I mean, yeah, if maybe sometimes people do not interpret marginal effects. They interpret only coefficients like signs, negative or positive influence, something like that.
Okay.
For instance, if first part of this Heckman correction procedure, people do not care about marginal effect. We care about whether we have statistical significant influence on our independent variable, of our independent variable on our dependent variable. I mean, it depends on your goal, on your aims, yeah. And here, this is again, you see the, yeah, so this, for instance, as you said, marginal effects are shown instead of coefficients. In this case, people show only marginal effects with no standard error, just marginal effect and their significance. You can do it in that way, for instance. Yeah, but you need to, in the note, you need to clarify what you chose. Yeah, like this one, for instance. Yes?
It's logical, yes.
Yeah. Then maybe most interesting part is like not article yet, but working paper, but USA, but in Russia is approximately the same. So it's presented of regressions based on the effect of our COVID on the probability to be employed or to be in so-called unpaid vacations. Yeah. So sometimes people present not every independent variables, but present only the most crucial. And this one is like other, in this case, in your node, you write other control variables. Suppose graduation study, female, yeah? Other control variables, look. Yeah, different stuff. This, yeah, so standard errors clusters at year level are reported in person, like in brackets, yeah. So, and this, look, the presented average marginal effect in the square brackets. So coefficients, yeah, errors, marginal effects, like three in one column, like other way to present the results. But what is more interesting, who more suffering during the COVID based on these results? Okay, look on the column number 4. What can you say from these numbers?
Female?
Yeah, female, because it's negative. Why do you think that female have higher probability to be unemployed, like low probability to be employed? Why in COVID situation females have low probability to be employed?
I'm trying to understand what is written in the different types of brackets.
This is, look, the square one is the standard error. Yeah. This one is the marginal effects.
So the I know the в общем, круглые скобочки. Is it marginal effects?
No, it's the error, standard error.
Okay. So in that case, marginal effect of being a female reduce your probability to be employed by approximately 22.3%.
Yeah, you're right. Percentage points. Yeah. Why do you think that? Any? Because we discussed labor market and basically the issues about labor market. What is a possible explanation for that? What do you think?
So
it's like any of your opinion.
And am I right that the zero category is male, right?
Yeah.
So maybe because there is a discrimination between male and female
yeah,
employees,
probably.
and
yeah, continue, sorry.
And so it was expected that it would be that way.
Yeah, probably. What other possible explanation? I mean, when you interpret the numbers, it can be number of possible explanation, of course. Yeah, one explanation, of course, it can be discrimination. What the other explanation? Okay, thinking that way. Are male and females work in the same job places?
No.
No. What are the most suffering sectors from the COVID?
Like service sector?
Yeah, what else?
The
borders are closed.
Yes.
Then what sector suffers?
Maybe some tourism
Yeah.
sector.
If you think about service sector and tourism, what do you think about share of females and males in this sector?
I reckon that the share of female is a way bigger than the share of males here. So
Yeah, so like think about it. Like most basically harmed sectors. Yeah, different share of males and females, and we look on the labor market at whole. Yeah, and if they with that most harm sectors in where the females are largest share, it means what? It means if we look on the whole labor market, we may see that the probability to be employed is lower for women compared to men because they just occupied in these sectors.
We in that case, if we have available data, we can check the probability of being employed by sectors
Yeah, for instance.
economy.
Yeah, of course. Or think about that way, like if there is a layoff of people, what category of workers is the first for this layoff? What category of positions, let's say in that way?
I know maybe someone who works with clients.
For instance, yeah. And if you think about top managers usually are males, yeah. And
Right.
then there is a layoff. Sometimes it's females, yeah. And if we think that there was like shortage of working person, probably top managers are still top managers, yeah. And then we have layoffs among like linear positions, so called, yeah, like working with clients, for instance. And
Right.
because we have a different distribution of males and females in this position, we may have situation when females have low probability to be employed during COVID. So it can be other possible number of explanation of this. Why I ask you that? Because when you have your numbers for your term paper, do not just have these numbers. Try to explain it. Try to explain why it can happen. Because, we made calculation not because of calculations, yeah, because we want to know something. And it's more crucial that you need to understand how to explain these numbers. Yeah, if you do really, really complex calculations but cannot explain the numbers, it means that you have no results, because why do you need these numbers if you cannot explain it? And because of this, econometrics try to teach you how to choose methods that can solve your problem and can tell you something about your research questions. Okay. Basically, we are done for today. We are even like 8 minutes more. Any questions about today method seminar? Let's call it that.
So, and if I want to practice those methods in R, I just need to Google them, and R will have pretty similar functions, right?
Yeah, I'm sure. I think it's like in standard library of R, you have this Probit models. I mean, these tests, it's like manually written. That like in Starter you need to download it additionally. But I think there are the same tests for R2. Just type like Probit in R.
Okay.
I think it's no problem. Like, because like this Probit is really, really, yeah. Look, this is the first I googled Probit regression R data analysis example.
Cool. Okay.
So, like, don't. It's the same name of the command. It's the same tables that you get from the R, so it doesn't matter what statistical software are you going to use. But nevertheless, I uploaded in Element this presentation, and if you want to practice the data set for starter format, but you can use the same data set for R2. I mean, data set you cannot use in R, so there's no problem. Okay, then see you in 15th of November. Please, those who are from finance econometrics, check the time for your debate and basically form the new groups of 3 new groups. So then we have 22 groups for our course, and we have additional debate on the 29th of November. But for 29th of November, this time is already taken. So we have only 2 slots, like 9:30 and 40 minutes past 2. So if it's this time is kind of really stick to you, then maybe you need to add it to some groups who has not 5 people. I hope it's clear. Then if you have no questions, nice to hear you. Have a good day, then bye.
Thank you. Goodbye.
Yeah, bye.